work, we're going to replace them with a little rational Bayesian agent. And then our rational Bayesian agents are going to go about choosing hypotheses by applying Bayes rules and then sampling a hypothesis from the posterior distribution, generating data in a way that's consistent with the likelihood hypothesis from the posterior data from the likelihood. So formulating things in this way then allows us to use some basic mathematical tools from the theory of Markov chains to analyze this process and to ask a question about what happens to these hypotheses as time goes on. And what we can prove is that in this case where learners are sampling from their posterior distribution, the probability that the learner chooses a particular hypothesis is going to converge to the prior probability which is assigned to those hypotheses by all of the learners as the chain gets longer. So here we make an assumption that the learners all share this prior distribution. What's going to happen is that over time, regardless of where the learners start out, they're going to end up with the probability of choosing a particular hypothesis converging to prior. So what this means in the context of thinking about the languages which are going to emerge from this process is that we're going to expect those languages which are easiest to learn to be the things which are going to come out of this. Those things which are assigned high prior probability are going to be those things which are going to appear as a consequence of this process of cultural transmission. And this gives us a very direct way of translating the deductive biases of those individual learners into the kinds of things that we expect to then see emerge across societies as a consequence of this process of transmission. It's worth saying that we actually have some other results which this is in joint work with Simon Kirby and Mike Dowman. We've studied how this changes if you make different assumptions about how these learners work. And as those learners move towards doing something like choosing the most likely hypothesis, rather than sampling from the posterior distribution, we can actually show that the effect of the prior is magnified. So they're going to converge to a distribution which basically is going to increase the probability of high prior probability and decrease the probability of low prior probability. So this process of cultural transmission can also emphasize those inductive biases of learners. Either way, this makes a prediction that what we should see emerging from these processes of cultural transmission is those things which are easy to learn. And that's a prediction that we can test out in the lab. So far I've been talking about an abstract mathematical analysis. We've done a number of experiments which explore the predictions of the signal in the context of laboratory experiments, where we actually know what kinds of things people find easy or hard to learn, and we can look at whether those emerge from these processes of cultural transmission. So one example of this is a simple case of concept learning, where the data you might get would be instances of a particular concept, and what you're trying to do is evaluate hypotheses about the full extent of that concept. In this case, each of our learners is going to see examples which are drawn from a species of amoeba. Species consists of 4 amoeba. The amoeba differ only in their nuclei, and these nuclei differ in their size, shape, and color, so it's 3 binary dimensions. So this is really a task where people are learning Boolean concepts which are expressed over a domain of 8 objects characterized along those 3 dimensions. In order to make this into an iterated learning task, what we would then do is then take the hypotheses that people select on one trial and then use those to generate the data which is going to be provided to the next person on the next trial, and then repeat that process again and again. And we can look at what emerges from that process of transmission. The reason why we use these stimuli, which seem quite a long way away from language, is that they're something which is being studied extensively by cognitive psychologists. So these stimuli defined in these 3 binary dimensions, if we restrict ourselves to sets of 4 objects, break down into just 6 basic types. And there's an ordering that's known in terms of the difficulty of learning concepts of those 6 different types. So type 1 concepts are expressed only along a single one of those binary dimensions. Here, everything that's in the